Let us now consider a Wedge-Dash structural representation of the tetrachloromethane. There are bond dipoles towards the chlorine atoms for each of the carbon-chlorine bonds, but because this molecule is completely symmetrical, the bond dipoles will cancel. It is helpful to look at the three-dimensional representation of a tetrahedral geometry. As mentioned earlier, the tetrahedral can be viewed as two bent structures joined at the middle carbon. As shown here, the dipole to the right between the two carbon to chlorine bonds will cancel with the dipole to the left between the other two carbon to chlorine bonds. This molecule is therefore not polar, has a zero dipole moment, and we don't draw a molecular dipole arrow. To help you see the requirement for symmetry for the bond dipoles to cancel, it is helpful to compare dichloro-difluoromethane to the tetrachloromethane. The wedge and dash structural representation show bond dipoles from the carbon atom to the chlorine and fluorine atoms. Because the fluorine atom is more electronegative than the chlorine atom, we draw larger, longer bond dipole arrows towards the fluorine atoms. Clearly, the electron distribution in this molecule is not symmetrical. The molecule is polar, and we would expect a molecular dipole in the direction of the region between the two fluorine atoms. Again, it is helpful to look at a three-dimensional representation of the tetrahedral geometry. As shown here, the dipole to the right between the two carbon to fluorine bonds is larger than the dipole to the left between the two carbon to chlorine bonds. Therefore, we would expect that this molecule indeed will have a molecular dipole towards the direction of the fluorine bonds.